In this video, we'll see about ergodic random process. Ergodic random process is one whose statistical mean is equal to the time average of that random process. So you know the statistical mean means this is the formula for the statistical mean. So minus infinity to infinity x is the value taken by the random process, and this is the PDF of the that random process. So this is the formula for the statistical mean, and if and this is the time average of xt, where you are taking the area under minus t by 2 to t by 2 of that random process divided by 1 by t, and limit tends to infinity. So if the observation interval is tending to the infinity, then your statistical mean is equal to time average in case of ergodic random processes. That means statistical averages are equal to the time averages. So the for non in that for the ergodic process or non-periodic ergodic process, you have to remember this one, that mu x square, that is mean square, that is equal to the dc power of random process is equal to rxx infinity. So this r is nothing but the autocorrelation function taken at infinity, and the mean square value, that is ex square t, that is total power, is equal to rxx of 0. So total power is equal to rxx of 0, that is autocorrelation function at 0th value. All these basics are there in the previous videos. So we have already seen strict sense stationary random process, then wide sense stationary random process. Now in this video we are seeing the ergodic random process. So this is the Venn diagram. So all the ergodic all strict sense stationary random process are wide, they have the properties of wide sense stationary random process as well as ergodic random process. Then all wide sense stationary random processes are ergodic, but it doesn't mean that ergodic is always all ergodic processes are WSSRP. Then it doesn't mean that wide sense stationary random process have all the properties of SSRP. We can say it like that: SSRP or SSRP has all the properties of WSSRP and ergodic. Ergodic doesn't mean that it has the properties of all the properties of WSSRP, and WSSRP doesn't have all the properties of triple SRP. We can say that the random space of SSRP is greater than WSSRP and ergodic random process. So what is independent identically distributed random process? Independent means the Independent means the random variables which you obtain by observing the random process at particular instance are statistically independent, and they are identically distributed means their statistical properties are similar. Suppose you observe the random process at t1, t2 and tk, you will get the random variables xt1, xt2, xtk. Now if they suppose instead of t1 and t2, you take t and t plus tau. These two instances you take. That means at t you observe the random process, and at t plus tau you observe the random process. Then statistical independence means expectation of x of t is equal to expectation of x of t plus tau. So and that is for the for the stationary random process, that is constant, that is equal to, that means mean is constant, it doesn't depend on the time, so that is equal to mu x. So for the statistical independent process, ext into x of t plus tau, we can write it as e of x t into e of x of t plus tau. So we know this is nothing but rxx of tau, that is autocorrelation at tau. Because autocorrelation for the stationary random processes depend on the time difference, and time difference here is tau. Now this is constant mu x, this is also constant mu x. So expectation of xt x of t plus tau is equal to rxx of tau. So rxx of tau is nothing but mu x square for the IID processes. independent identically distributed processes. So Rxx tau is equal to mu x square. Now, uh, so if you put the tau equal to 0, again you will get E of x square t, and that is equal to Rxx of 0. This is called total power. So this is it for this video.